Bismillahirrahmanirrahim. Quote of the day is a hadith from Holy Prophet, peace be upon him. Whoever follows a path in the pursuit of knowledge, Allah will make a path to Jannah easy for him. Assalamu alaikum. I'm Dr. Nabeela Umar, working as PGR in community medicine. Today I'm going to present the topic of basic biostatics under the kind supervision of Professor Dr. Saida Afzal. Learning outline. Introduction, common statistical terms, types of data, presentation of data, types of biostatistics, sampling and sampling methods, and at the end, multiple choice questions. Learning outcome. At the end of the presentation, participants will be able to describe the basic concepts of biostatistics, types of biostatistics, techniques of presenting data and its various types, descriptive and inferential biostatistics. Introduction. Biostatistics is a Latin word derived from word status, meaning information valuable to the state, such as the size of the population and the size of the armed forces. Statistics refer to the numerical facts that are gathered from sample populations. When the data we use are biological, medical, or health-related, the subject is called biostatistics. Biostatistics is defined as the procedures and techniques used to collect, process, and analyze data to make inferences and to reach decisions in the face of uncertainty. The field of statistics is concerned with how the data is gathered, presented, calculated, analyzed, and then interpreted. There are 5 stages or steps in any statistical investigation. Number 1 is the collection of data, which is the process of obtaining measurements or counts. Then the data is organized, which includes editing, classifying, tabulating the data collected. Then the data is presented, overall view of what the data actually looks like. It facilitates further statistical analysis. It can be done in the form of tables and graphs or diagrams. Then there is analysis of data. To dig out useful information for decision making, it involves extracting relevant information from the data like mean, median, mode, range, variance. Interpretation of data, concerned with drawing conclusion from the data collected and analyzed and giving meaning to analysis result, a difficult task and requires a high degree of skill and experience. Various terms of biostatistics. Population, a group of persons who share some common characteristics. What is a sample? It's the process of picking persons from a group of available observations. It constitutes a sample. Variable, a characteristic that takes on different values in different persons, place, and things. Data is a set of values recorded on one or more observational units. Statistic is a characteristic or measure obtained by using the data values from a sample, and parameter is a characteristic or measure obtained by using all the data values from a specific population. Now, what is data? Information gathered on a sample or a population is referred to as data. It is a piece of information such as height of a person, weight of a baby. When tools of statistics are applied to the data that is derived from biological sciences such as medicine, it is termed as biostatistics. There are various types of data. We can divide data into quantitative and qualitative data. Quantitative data is further divided into continuous and discrete, and qualitative data is divided into nominal and ordinal. Quantitative data. It is divided into discrete and continuous. Discrete reflects a number obtained by counting, which includes no decimal. And continuous reflects a measurement. The number of decimal places depends on the precision of the measuring device. It includes a ratio scale and an interval scale. Ratio scale is an order and distance applied. Interval scale and the order and distance applied, difference can be compared, and it has no true zero. Ratios cannot be compared. For example, temperature in Celsius. Qualitative data. It is divided into ordinal and nominal data. Ordinal data is the difference and order are implied, but intervals are no longer equivalent. For example, ranking system. Nominal data, only difference is applied. Observation are classified in mutually exclusive categories. Examples include gender, ID numbers, or a pass or fail ratio response. Collection of data. Data can be collected through primary sources and secondary sources. Primary sources, the data here is obtained by the investigator himself, and secondary sources, the data already recorded is utilized to serve the purpose of the objective of the study. For example, records of the OPD and dental clinics. Presentation of data. To sort and classify data into groups or classification, there are 2 main methods used, tabulations and charts and diagrams. The objective is to make the data simple, concise, meaningful, and helpful for further analysis. This is how the data is presented. This is the tabular presentation of the data. Underneath is the bar diagram, then is the pie diagram, and this is the histogram. Types of biostatistics. There are two main types, descriptive biostatistics and inferential biostatistics. What is descriptive statistics? This is the statistics which deals with descriptive section of the data set as well as tendency to describe the data set initially. Descriptive statistics are numbers that are used to summarize and describe the data. The word data refers to the information that has been collected from an experiment, a survey, a historical record, etc. Whereas inferential statistic is the sample is a set of data taken from the population to represent the population. Probability distributions, hypothesis testing, correlation testing, and regression analysis all fall under the category of inferential statistics. Descriptive statistics. It summarizes, describes, and characterizes a sample being studied. It determines if the sample is normally distributed, bell curve. Most statistical tests require the sample to have normal distribution. Determine if the sample can be compared to the larger population. Descriptive statistic is displayed as tables, charts, percentages, frequency distributions, and reported as measures of central tendency. How to interpret descriptive statistics? It includes the measures of central tendency, measures of variation, measures of position, and exploratory data analysis. Measures of central tendency. It is a variable usually has a point around which the observed value lies. The three most commonly used averages are the arithmetic mean, the median, the mode. Now, what is arithmetic mean? The answer is calculated by dividing the total number of observations by the sum of all the values. The letter X is used to symbolize this entity, and this is the formula we use for calculating arithmetic mean. It has an advantage is it is simple to calculate and indicates the central tendency, but its disadvantage is that extreme values influence the data. What is median? When the data is sorted in either ascending or descending order, median is the value that splits the data into two equal proportions, known as the midpoint. Its advantage is that it is not affected by the extreme value, but its disadvantage is that measurement is not exceptionally exact. If there are odd number of values, we use the formula n plus 1 divided by 2. And if there are even number of values, then we have the formula n divided by 2. What is mode? The figure that appears most frequently in the data set is known as mode. Its disadvantage is that the measurement is not exceptionally exact, may not exist, or may not be uniquely defined. Now, how the data is distributed? There are two types in which the data is distributed. Number one is the normal distribution. Commonly, the data are seen distributed along with normal distribution, the most often encountered distribution in a health-related setting. Its important characteristics are it is symmetrical about its mean, it forms a bell-shaped curve, the mean, median, and mode all located at the same position. The distribution is found in most continuous variables. The data having normal distribution underlies parametric tests. The second type in which the data is distributed is the skewed distribution. It is an asymmetrical distribution. The mean, median, and mode are all located at different positions on graph. It is classified as positively skewed distribution of data and a negatively skewed distribution of the data. When the data has a skewed distribution, non-parametric tests are used to analyze it. Descriptive statistics, measures of spread. The spread refers to how the data deviates from the position measure. It gives an indication of the amount of variation in the process, an important indicator of quality and used to control process variability and improve the quality. There are different statistics by which we can describe the spread of our data. Number one is range and the other is standard deviation. Range is the difference between the highest and the lowest values. The simplest measure of variability, often denoted by R. It is good enough in many practical cases and does not make full use of the available data. It can be misleading when the data is skewed or in the presence of outliers. Standard deviation. The average distance of the data points from their own mean. A low standard deviation indicates that the data points are clustered around the mean. A large standard deviation indicates that they're widely scattered around the mean. The standard deviation of a sample is denoted by S, and the standard deviation of a population is denoted by sigma. What is inferential statistics? Inferential statistics is the technique used to draw conclusions about a population by testing the data taken from the sample of that population. It is the process of how generalization from the sample to population can be made. It is assumed that the characteristics of a sample is similar to the population's characteristics. It includes testing hypotheses and driving estimates. Focuses on making statements about the population. The process of inferential analysis. Number one is the raw data. It comprises of all the data collected from the sample. Depending on the sample size, this data can be large or small set of measurements. Then sample statistics. It summarizes the raw data gathered from the sample of population. These are the descriptive statistics, for example, measures of central tendency. And then the inferential statistics. These statistics then generate conclusions about the population based on sample statistics. Sampling methods. There are two types of sampling methods. One is the probability sampling and the other is the non-probability sampling. Probability sampling includes the simple random sampling, systematic sampling, stratified sampling, and cluster sampling, whereas non-probability sampling includes convenience sampling, voluntary response sampling, purposive sampling, and snowball sampling. Probability sampling. It is the approach in which the researcher specifies a few criteria and randomly selects the members of the population. All the participants have an equal chance of being included in the sample. For example, every member of a population of 1,000 has a 1 in 1,000 probability of being picked to participate in sampling. Its types include random, systematic, stratified, and cluster. Random sampling. All candidates have an equal chance of being chosen. For example, for conducting the investigation, we are planning to select 100 employees out of 1,000 workers in a company. We can give random numbers to all the 1,000 employees, and by using the random sampling technique, we can select 100 workers. While applying this method, we need to make sure that the sampling structure which has been chosen covers the entire population. Systematic sampling. A random selection process is employed to choose a subgroup of data. For example, a researcher wishes to compile a systematic sample of 500 individuals from a population of 5,000. They then assign a number to each member of the population between 1 and 5,000 and select every 10th individual for the sample. The total population divided by sample size, the answer will be 10. Stratified sampling. The stratified sampling method can be applied where the population involves mixed characteristics and we want to make sure that we have represented characteristics by dividing into different strata and selecting samples from each stratum. Researchers can use sampling bias and draw more accurate conclusions. Cluster sampling. A group of people of things gathered in space or time to save money. While applying this technique, we need to make sure that every group consists of similar characteristics. For example, we want to conduct an investigation in order to analyze whether employees working in an organization are satisfied with the working environment. Companies where we want to perform surveys research consist of 1,000 employees. Kingfisher Airlines has 12 branches located in different cities. In such a way, we cannot मुझे आपने कल भी नहीं बताया मैंने ना मुझे जरूर बताया दिखाती you can select 5 offices randomly which is basically your cluster. अच्छा 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 ठीक है फिर मुझे अभी जरूर बताइएगा आती है आना भी नहीं आना है थोड़ी देर मुझे जरूर बताइएगा चलिए ठीक है Cluster sampling. A group of people or things gathered in space or time to save money. Next is the no probability sampling. The researcher randomly selects participants for the investigation. This technique makes it hard to ensure that all segments of the population have a chance of being included in a sample. It includes convenience, snowball sample quota. Convenience sampling. This method relies on easy access to subjects. It is easy for researchers to conduct and contact the participants. It is used when time, money, and resources are limited, such as in early phase of research. The researcher selects those participants who are easily accessible to the investigator. The major drawback of the method is that you can't make sure people whom you have selected as participants represent the entire population. Purposive sampling. Samples are chosen at random by the researchers, and researchers only examine the study goal and the target audience. Snowball sampling. It is used when tracing people is challenging, and the investigators review a few categories and get conclusion. Probability is the mathematical possibility that a certain event will take place. They can range from 0 to 1. Parameters describe the characteristic of a sample of a population, variables such as age, gender, income, etc. Statistics describe the characteristic of a sample with the same types of variables. And sampling distribution is used to make inferences based on the assumption of random sampling. Sampling error. Inferential statistics take sampling error into account. It is the degree to which a sample differs on the key variable from the population. Confidence level. The number of times out of 100 that the true value will fall within the confidence interval. Confidence interval is the calculated range for the true value based on the relative size of the sample and the population. Sampling error describes the differences between sample statistics and population parameters. Confidence interval. It provides a range of values within which the actual population mean lies. It is frequently reported as a 95% confidence interval, which means that one can be 95% certain that the actual value is within the data range. The 95% confidence interval is calculated as the mean 2 plus standard error of the mean. Hypothesis testing. During investigation, there is assumption and presumption, which subsequently in study must be proved or disapproved. Hypothesis is a supposition made from observation. On the basis of hypothesis, we collect data. Two hypotheses are made to draw inference from the sample value. Null hypothesis or hypothesis of no difference, alternative hypothesis of significant difference. The null hypothesis and the alternative hypothesis are chosen before the sample is drawn. Alternative hypotheses specify expected relationship between two or more variables, and null hypothesis is the statement that says there is no real relationship between the variables described in the alternative hypothesis. In inferential statistics, the hypothesis that is actually tested is the null hypothesis. Therefore, it is essential to prove that the null hypothesis is not valid and alternative hypothesis is true and should be accepted. Possible outcome of a hypothesis test. There are two types of errors. Type 1 error occurs if you reject the null hypothesis when it's true, and a type 2 error occurs if you do not reject the null hypothesis when it is false. Conceptualizing central tendency and dispersion in applied statistics. In any research to summarize the huge collected data for describing its characteristics, frequency distribution or histograms are used to reduce the heap of data. Statisticians use a variety of numerical measures or indices in order to summarize data in a concise yet informative manner. The other way of representing the bunch of data is the tabular, diagrammatic, and graphical approaches that visually illustrate the unorganized data. There are many methods of describing the characteristics of the collected data. The averages are the measures that condense a hugely unwidely set of numerical data into single numerical values, which are representative of entire distribution. And measures of dispersion show the information about the normal amount of variability or deviation or scatteredness or variation of the data from the average or central value. Population research, convenience sampling strategies. In the circumstances where the entire population cannot participate in a study or the members of the target population cannot all be identified, sampling is employed to gather data that are presumed to be representative of the target population. There are two primary categories of sampling strategies used in population research. First is probability sampling. In each member of the target population has an equal probability of being selected as a study participant. The second is the non-probability sampling, in which the researcher uses sampling that does not provide for each member of a target population to participate in a study, and rather the participants are selected by the researcher. Convenience sampling is non-probability sampling that is often used for clinical and qualitative research. This technique often selects the clinical cases or participants that are available around a location, such as hospital, medical records, database. Convenience sampling for qualitative research depends on the motivation of those who participate in the research. In addition, there is risk of limited cases or poor participation rates for convenience samples. This raises the risk that significant data are not detected for case-based clinical studies. Non-participants should be reported for qualitative research. For example, a response rate of 60% would generate a potential error of plus or minus 20% for any conclusion drawn from the research. Multiple choice questions. Now, MCQ number 1. The summary statistics which measure the middle or center of the data are called A. Logarithms, B. Measure of central tendency, C. Measures of dispersion, D. Measures of shape, or E. Proportions.
B. Measure of central tendency.
B.
Year of central tendency.
Yes, the answer is B, measure of central tendency.
B.
MCQ number 2. Variables whose values cannot be expressed numerically are called A. Quantitative variables, B. Qualitative variables, C. Absolute variables, D. Continuous variables, or E.
B.
Instrumental variables.
B.
B. B.
B.
Qualitative.
Yes,
Qualitative.
yes, the answer is quantitative variables. MCQ number 3.
Qualitative.
Statistical data analysis is a procedure if performing various statistical operations. It is a kind of quantitative research. The average of all observation in a set of data is called A. Mean, median, mode, range, or standard deviation.
A. A.
Mean.
Mean.
Yes, the answer is A. Mean.
Mean.
MCQ number 4. Failing to reject the null hypothesis when it is false is A. Alpha error, B. Type 1 error, C. Beta error, D. Type 2 error, or E. Type 3 error.
B.
Beta error.
The answer is D. Type 2 error. MCQ number 5. Ranking students from the individual with the highest grade points average to the lowest is an example of nominal data, B. Ordinal data, C. Interval scale, D. Ratio scale, or E. Alphanumeric.
B. B. Ordinal.
B.
Yes,
Ordinal.
B. Ordinal data. MCQ number 6. A researcher wants to estimate the average BMI of university students in Lahore. He selects a random sample of 500 students. The estimate is reported with a 95% confidence interval. What does it mean? 95% of the students in the university have a BMI within this range. B. There is a 95% probability that the sample mean is correct. C. 95% of the similar sample would contain the true population mean. D. The sample mean is exactly within this range. Or E. The margin of error is 95%.
A.
A. A.
C.
The answer is C. 95% of the similar sample would contain the true population mean. MCQ number 7. Qasim is 59 years old and presented with continuous significant weight loss for past 3 months. During ward round, professor talked about stages of cancer. The stages of malignant disease is recording using the symbols 0, 1, 2, 3, and 4. We say that the scale used is alphanumeric scale, B. Numerical scale, C. Nominal scale, D. Ordinal scale, or E. Interval scale.
B.
Ordinal.
B.
Nominal.
Nominal.
The answer is D. Ordinal scale.
Ordinal.
MCQ number 8. A hospital administrator wants to understand the variation in patient weight in different emergency departments. Which measure is most appropriate? A. Mean, B. Median, C. Standard deviation, D. Mode, or E. Range.
C.
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 The answer is C. Standard deviation.
Standard deviation.
MCQ number 9. A researcher wants to select 50 students from a university of 5,000 students. He assigns numbers to all students and select every 100th student. Which type of sampling is this? A. Simple random sampling, B. Systematic sampling, C. Stratified sampling, D. Clustered sampling, or E. Convenience sampling.
Systematic
B.
sampling.
Systematic. B.
Yes, the answer is B. Systematic sampling. MCQ number 10. A researcher collects data on the number of hospital admissions for pneumonia over the last 10 years. Which type of data is this? A. Continuous, B. Interval, C. Discrete, D. Nominal, or E. Ordinal.
A. Continuous.
Continuous.
Continuous. C.
The answer is C. Discrete. This is the key to the MCQs. This is the YouTube channel where the presentation will be uploaded. Thank you all for your attention.
हाँ पॉइंट नहीं हो सकता ना इंसान या एक होगा या दो होंगे ओके थैंक यू